Hello students, in this lecture we are going to see how we are deriving the equation for Bresenham circle drawing algorithm. Now as you know that when we are drawing any circle on the screen, then we are using the 8-way symmetry. 8-way symmetry indicates that suppose this is the x-axis, this is the y-axis, and again we are passing here the two lines which will divide this circle into the 8 different quadrants. This is the first quadrant, second quadrant, third quadrant, up to this. These are the 8 quadrants. Now 8-way symmetry means when we will find out the pixels for the one quadrant, we can map the pixels from the other quadrant also by taking the negative and positive coordinates as per the axis and its axis values. So if we are finding out this quadrant, then it is very easy to find out the other values by mapping the same coordinates into the other quadrants. Now this is a circle which is having the r radius. Always we are deriving the equation which for the circle which is having the center as a 0 0, and then we are transforming it to our required center. Now let us see the how we are deriving the equation. Now as you know that our main aim is to find out which pixel we have to illuminate. Now for example, if we are at the current pixel and we have plotted this p1 pixel having the xk and yk coordinates. Now we have to take the decision that whether we have to illuminate this p3 pixel or p2 pixel, because the line is passing in between these two pixels. So either p3 gets selected or p2 gets selected. For that purpose, it is required to find out the distance between p3 pixel to the line and p2 pixel to this circle line. Now consider that the distance from p3 pixel to the line is d1 and from the pixel p2 to the line is d2. Now whatever be the less, suppose d1 is less, then we are plotting p3 pixel, we are ignoring p2 pixel, and when d2 distance is less, then we are plotting the p2 pixel. Now when you will observe the p3 and p2 pixel, either p3 or p2, any one of the gets selected, but here the x is always incremented. In p3 pixel the coordinates are xk plus 1. In p2 also x coordinates are xk plus 1. So either we are selecting p3 or p2, our x coordinates are increased. Now this is very important terminology. Now in p3 y remains same, but in p2 y is decreased by 1. So either xk will be increased, xk must be increased by 1, but either yk remains same or yk is decreased for selection of the next pixel. Now our aim is to find out the decision parameter, derive the equation for the Bresenham circle drawing algorithm. So for that purpose, we are considering the equation of any circle circle with x and y coordinates is represented by x square plus y square equal to r square. Now let us assume we are having the point P1 as a xk, yk on the boundary of a circle. Now we have to decide which point we have to select, whether the P3 or P2. The distance between the point P3 to the circle line, circle boundary is a D1 and it is a D2. Now if we will select the pixel point P3, then what are the coordinates of the P3 pixel? The coordinate of the P3 pixels are nothing but a x k plus 1, k plus 1, and yk is same. So these are the coordinates of a P3 point. So we are deriving the equation for the P3 as a D1 equal to xk plus 1 square. Why xk plus 1 square? Because the coordinate for this P3 pixel are xk plus 1 and y coordinates are yk. So yk square, x square, yk square minus r square. Similarly, we can derive the equation for the P2. P2 coordinates are xk plus 1, but y coordinates are yk minus 1 square. So D2 equation is derived as a xk plus 1 square plus yk minus 1 square minus r square. When you will observe this equation, D1 is always having the positive value. Why the positive value? Because this pixel P3 is fall outside the circle. So obviously this value is greater than the radius of a circle because it is outside, and always the P2 is having the negative value. Why? Because this pixel always falls inside the circle boundary, and obviously this radius of the circle is always greater than this x and y coordinate. So minus r square, so it is always a negative value. So now let us calculate the decision parameter. Every decision parameter is calculated by using the D1 plus D2. When when the D2 is greater, that means this value is a greater. This value greater means dk is less than 0. Dk becomes a less than 0. So it is value is greater. D2 is a greater means D1 is a small. So we are plotting P3 pixel. If D1 is greater means value is always a positive and this negative value is small. So positive value is greater. If it is a greater, then we are plotting the P2 point because D2 is smaller. So if the value of dk is less than 0 means D2 is greater. So always it will come as a negative, less than 0. So point P3 is closer because D2 is a greater value, and the point will be plotted as xk plus 1 comma yk. If dk is greater than or equal to 0, when it will come as a dk is greater than or equal to 0? When this value D1 is a greater, because it is a negative value, it is a positive value. So when it is having the greater value means dk is positive, and we are plotting the P2 pixel because as this is a greater, so this is a smaller. D2 distance is of P2, so we are plotting the P2 pixel. Now let us go for the calculation of the decay. So we are putting in equation the two equations we have calculated for the D1 and D2. D1 equation is this one and D2 equation is this one. Then we are reducing this equation. Xk plus 1 square plus xk plus 1 square becomes 2xk plus 1 square. Now we are remaining equation as it is. Now we are calling it as a, consider that this is the equation number 1. Now let us calculate the initial decision parameter that is required when we are plotting the first pixel. When we are plotting any first pixel, its coordinates are always a 0 comma r. Now why the 0 comma r coordinates are there? For example, now suppose this is a circle. Now this is a circle. We want to draw this circle. Now here we know the center point, we know the radius r. So what are the pixels we know? At least one pixel we know. The coordinates of one pixel we must know. So how we will find out these initial coordinates? That is nothing, the x value is a 0. I have already told that we are considering the center point as a 0 comma 0. So x value is 0 and y value is a r. So we are plotting this pixel and finding what are the initial decision parameters, and then we are going for the next pixel finding by using the next decision parameter. So let us calculate the initial decision parameter value. So for that purpose we are putting xk equal to, now this is the equation dk. First equation, in equation 1 we are putting xk equal to 0 and yk equal to r. So let us put xk equal to 0, yk equal to r. Here r minus 1 square, it becomes minus 2r square. Now in this equation 0 plus 1 1 square 1. So 2 into 1 2, then r square plus, now we are expanding this term, r minus 1 square, r square minus 2r plus 1 minus 2r square. So by solving it, 2 plus 1 becomes a 3, r square plus r square, 2r square minus 2r minus 2r square. So this 2r square and 2r square get cancelled, and we are getting the initial decision parameter as a 3 minus 2r at this position. So always there is a need, whenever we are drawing any algorithm, initial decision parameter is must. So initial decision parameter d0 equal to 3 minus 2r. So hope so this is a clear how we are calculating the initial decision parameter. Now let us calculate the next decision parameter, dk plus 1, because we have to plot, we know xk, yk, but we have to find what is the next coordinates, xk plus 1 or yk plus 1 or yk minus 1. So for that work purpose we require to calculate dk plus 1. So very simple, in previous equation of dk, only instead of a k, put there k plus 1. We will get an equation as a dk plus 1. In previous dk, we have, instead of a k, we have put in every term k plus 1. So 2xk plus 1 plus 1 square plus yk plus 1 square plus yk plus 1 minus 1 square minus 2r square. Now as you know that when we are incrementing, xk plus 1 is always an incremented value, but we cannot decide what will be the yk plus 1. Either it will be a yk or it will be a yk minus 1. But xk plus 1, always a next x is incremented by 1. So let us replace xk plus 1 by xk plus 1. So and we are keeping the yk plus 1 term as it is, because we don't know that whether it will become a yk or yk minus 1. So instead of a xk plus 1, we have written xk plus 1. So this equation becomes xk plus 2 square. So we will call it as a equation 2. So now we found now there is a need to find out the difference between dk plus 1 minus dk, because we want to derive actual what is the equation for dk plus 1. For that